All right, here is the key to your review. The numbering is all crazy, but just ignore that. It wasn't worth me fixing. So the first section says, using the leading term, give the end behavior of each polynomial function. So remember, when you're looking at the leading term, it doesn't always mean the first term. It is the term that has the highest exponent. In this case, it is the first term, so it's 2x to the 6th. It's even, so it's going to model a quadratic. And it's positive, so the end behavior is up, up. Here, the leading term is the negative x to the 8th. And since it's even, it's going to model a quadratic. Since it's negative, it's going to be down, down. Okay. And then we need to, on 9 through 11, we're going to determine the sign of the leading coefficient and whether it has an even or odd degree. So the ends are opposite, which means it has an odd degree. And a cubic would look like this. That's our parent function for a cubic, and that's opposite of that, which means it has a negative coefficient. The end behavior here is down, down. It's the same, which means that it would be an even degree. That models the end behavior of a quadratic. And since it's been flipped, then we have a negative coefficient here as well. The ends are opposite, which means it's odd degree. Again, with the cubic, it's pointing the same way. It did not reflect. Therefore, it's a positive coefficient. All right, so the next section says to divide the polynomials. I'm using synthetic or long division. And then on 13, we're also supposed to fully factor it and state the zeros. So if I can use synthetic division, I'm going to use synthetic division. And I can here. So that means on the outside here goes a negative 2. On the inside, I want to, let's see, this is x cubed, which means I have to have 4 numbers in here. There's only 3 here, which means I have a missing factor, or I'm sorry, a missing term. So this is 3 that goes with the x cubed. X squared is 9. There is no x term, so I have to have a 0 and then a negative 9. And then I put on my basement. Okay. Bring down my 3. This negative 2 times 3 is a negative 6. 3, negative 6, negative 6, positive 12, positive 3. So my answer here then, there's 3 terms, which means my leading term is squared. So 3x squared plus 3x minus 6 plus 3 over x plus 2. Okay. So on this one, I am supposed to, better write a little smaller because I'm supposed to fully factor it as well. And again, I can use synthetic division, so that's what I'm going to do. On the outside is a 1. It's x to the 5th, so there should be 6 numbers I have in here. 1, 2, 3, 4, 5, 6. Okay, I have 6 terms, so that's good. So this is a 1, negative 1, negative 13, 13, 36, and negative 36. So since I can fully factor it, that does tell me that x minus 1 should be a factor of this, which also means that my remainder should be 0, which I don't necessarily have to put that in there right now, but if I don't get 0, I did something wrong. So I bring down my 1, 1. 1 times 1 is 1, that's 0. 1 times 0 is 0, negative 13. 1 times negative 13 is negative 13. That's 0. 1 times 0 is 0. 36. 1 times 36 is 36. I do get 0, just like I expected. So since I am factoring this, I know that I have f of x equals, one of the factors is x minus 1. And then the result of this will go right here. This is 1, 2, 3, 4, 5 terms, which means it's an x to the 4th. So this my coefficient of 1 goes on x to the 4th. There is no x cubed, so it would be minus 13x squared. There is no x term, then plus 36. So then I have to factor f of x is equal to x minus 1. A is 1, so I can jump to my two parentheses that have x squared and x squared. Two numbers that will multiply to give me 36, combined to give me negative 13, will be negative 4 and negative 9. These are both difference of squares, so I can factor some more. So I get x minus 1 times x plus 2 times x minus 2 times x plus 3 times x minus 3. Right, and then the final part to this is I have to have my zeros. So my zeros are 1, plus or minus 2, and plus or minus 3. That's it. So on 14, I cannot use synthetic division, so I'm going to have to use long division. Board, catch up with me here. Come on. Okay. So when you start your long division, make sure you leave yourself some space to write your answer up at the top here. So I'm going to have 5x minus 1 on the outside. I'm going to have 20x cubed. Okay, so again, x cubed, I should have 4. There's 4 terms because I need 4 in here. I have an x cubed term, then minus 4x squared plus 10x plus 1. All right, so 20x cubed divided by 5x is going to give me 4x squared. I multiply it back. Will give me 20x cubed minus 4x squared. Okay, so then I change the signs here. These zero out and these zero out. So I bring down my 10x and I bring down my plus 1 since I zeroed out 2 of them. 5x goes into 10x 2 times, so I put it above this. I'm not going to have an x term. Multiply it back, and I'm going to get 10x minus 2. I change the signs. Those zero out, and I get a 3. So my final answer is going to be 4x squared plus 2 plus 3 over 5x minus 1. All right. This I definitely cannot use synthetic division on, so it's long division. X squared plus 6x plus 1 on the outside. On the inside, I get 3x cubed plus 20x squared plus 14x minus 8. There were no missing terms, but make sure you always check. All right, so 3x cubed divided by x squared is going to be 3x, so I put it above my x term. Multiply this back, I get 3x cubed plus 18x squared plus 3x. I change the sign on each one of them. These zero out. This will give me 2x squared plus 11x minus 8. 2x squared divided by x squared is going to give me a positive 2. So I get 2x squared plus 12x plus 2. I change the signs on this. These zero out. This gives me a negative x minus 10. Then my answer is 3x plus 2 plus, you always add your remainder. Numerator is negative x minus 10 over x squared minus 6x plus 1. If you were to just drop this negative down here, the whole thing would be wrong, because that's not the way it works on the fractions. That's why I've said over and over again, it is safest to just always add your remainders and you don't have to overthink it. Okay, there's page 1. All right, so now we're going to use the remainder theorem to evaluate f of x at x equals c. All right, so remainder theorem means we just get to use synthetic division. You can put a 3 out here. Got a 1, a -4, a 1, and a 6. So I bring down my 1. This is 3, -1, -3, -2, -6, 0. So that means that f of 3 equals 0, because that's where I get it from. That means that x minus 3 is a factor of that, by the way. Okay, so next one, got a -2. 4, it's x to the 4th, 1, 2, 3, 4. I should have 5 terms. I'm missing a squared, so I've got to be careful. 4, -3, 0, 7, -11. Then I bring down my 4. Got -8, -11, 22, 22, -44, -37, +74, and a +63 in there. So then that means that f of -2 equals 63. All right, another one. 1 goes out here. X to the 4th, I should have 5. 1, 2, 3, 4, 5. Okay, no missing terms. So I have 1, -6, -3, 2, and 2. Put my little basement where my answer will be. Bring down the 1. 1 times 1 is 1. -5, -5, -8, -8, -6, -6, -4. So f of 1 equals -4. Last one of these, I'll have a -3 out here. Then x to the 4th, so I should have 5, 1, 2, 3. There's only 4, so I'm missing an x squared term again. So I have 2, 5, 0, 3, and 4. My little basement. Then I'm going to have, I'll bring down my 2, -6, -1, 3, 3, -9, -6, 18, and 22. So that means then that f of -3 equals 22. Alrighty. Alright, so here's one of our K problems. So on these, when I have x plus 1 and I have this, I'm going to use my synthetic division, so I'll have a -1 outside. This is x cubed, so I should have 4 terms. I'm missing my x squared term again. Seems to be a popular one to be missing. So I have 1, then 0, then k, then 9. Okay. So when I do this, I should have something to fill in for my remainder, and since it says is a factor, my remainder is 0. All right, so I bring down my 1. And this is -1, -1. This is 1. So this is k plus 1, multiplied by a -1, so I'd have negative times k plus 1, which means that when I go to solve this, 9 minus k plus 1 equals 0. Oh, hang on, I wrote that wrong. Back it up. Back it up. 9 minus k plus 1. Quantity, there's parentheses there, I missed them. Right, so I need to distribute my negative, so this is 9 minus k minus 1 equals 0. So that's -k plus 8 equals 0. So 8 equals k, which means k equals 8. Right, did you have to distribute? No, you could have subtracted and then divided by a negative. And then subtracted the 1. I mean, it works. There's different ways to do it. I probably would have done it the other way had there been a number here, not just a negative. Okay, So here's another k problem. So outside I'll have a 3, inside it's cubed, missing my x squared term again, 1, 0, k, and 9. Okay, so this time it does not say that it's a factor. It gives me the remainder being 27, so I need that in there. All right, so I bring down my 1. 3 times 1 is 3. That's 3. That's 9. So this is k plus 9. So this is 3 times k plus 9. So when I go to solve this, I have 9 plus 3 times k plus 9 equals 27. So I'll subtract 9. 3 times k plus 9 equals 18. Divide by 3. K plus 9 equals 6. So k equals a negative 3. All right, on these next ones, I have to identify the zeros, their multiplicities, and describe the effect on the graph. Okay, so this one's already factored for me. That's nice. So my zeros, my smallest one is negative 7, then 0, then 3 halves. So I've got negative 7, 0, and 3 halves. So negative 7 came from here. The multiplicity is 5. Since it's odd, that's what gives you my wiggle, but remember the real words is point of inflection. The 0, that's odd, it's 3, so that's also a point of inflection. The 3 halves, that's even, that's 2, so that means that it's the bounce, but the real word for that is tangent. Then on the next one, I'm going to have to factor. So I get, let's see, I have a GCF here. So I'll factor out my x cubed. That leaves me with x cubed minus 2x squared minus 4x plus 8. Then I can factor by grouping. X cubed, so it'll be x squared times x minus 2 minus 4 times x minus 2. So 0 equals x cubed times x squared minus 4 times x minus 2. And I've written too big. I'm running out of room, so I can still factor that. So I get x cubed times x plus 2 times x minus 2 times x minus 2. All right, which means that I have f of x is equal to x cubed times x plus 2 times x minus 2 squared. All right, so then my zeros are, see, my smallest one is negative 2, then 0, then 2. So negative 2, 0, and 2. So for negative 2, the multiplicity is 1, which means it just passes through. It's just boring. 0, it's 3, so that's a point of inflection. And then the 2 is squared. The 2 is 2, so that means that it is tangent. Right? And then that is it for page 2. All right, last page. So I just realized on here that I should have said that these should have like a f of x equals on them. I had to fix them and I had to go retype them somewhere else, and I forgot the f of x. All right, because if it's not an equation, you can't solve it, and you have to solve it to find the zeros, so that's the way that works. All right, so that means here I'm going to start factoring. A is 1, so I can do 0 equals. So I've got x squared and x squared. This is negative, so the signs are opposites. Negative 3, so that'll be 1 and a 3, and the 3 will have to be positive. This is a difference of squares, so I can continue And this will be x plus 1 times x minus 1. Right, that's as much as I can factor right now. So I'm going to go and find my zeros. And so this will give me x squared equals a negative 3. So x equals plus or minus the square root of negative 3, which means x equals plus or minus I times the square root of 3. Then here, this is just going to give me x equals negative 1 and x equals 1. So my zeros are negative 1 and 1, and negative I square root of 3, and I square root of 3. Notice that it does say, find all zeros. This is part of it. Here are my zeros. Then I give the complete factorizations. So f of x is equal to x plus 1 times x minus 1 times x plus I square root of 3 times x minus I square root of 3. There's my complete. Here are my zeros. Here's my complete factorization. Okay, so on this one, I'm going to factor by grouping. So it'll give me x squared times x plus 2. I'm going to factor out a negative 12. I get x plus 2. So 0 equals x squared minus 12 times x plus 2. Okay, so that's as much as I can factor with my good old factoring. So I'm going to come in here and find my zeros. This means I'll get x squared equals 12. So x equals plus or minus the square root of 12. I have to be able to simplify that square root, and that is 2 square roots of 3. And then this will be x minus, oh my goodness. X equals negative 2 is what I'm trying to say. All right, so then my zeros are negative 2 square root of 3, and 2 square root of 3. There are my zeros. Then my function, completely factored, would be, so this negative 2 is going to give me x plus 2 times x plus 2 square roots of 3 times x minus 2 square roots of 3. There's my complete factorization. All right, so now we're going to take something that was completely factored, basically, and we have our zeros and our y-intercept, and we're going to write the polynomial. So remember, these squigglies wasn't worth me putting back in. All right. So I start by saying f of x is equal to a. We'll go figure out a in a minute. And then I get my factors from here. I have a 1, so this is x minus 1, and the multiplicity is 2. Then this does not give me x minus 4/3. This gives me 3x minus 4. So then I need to find a. So my y-intercept is a negative 8. That's equal to a times, then I substitute in 0 for x, so I get negative 1 squared times negative 4. So negative 8 is equal to, so negative 1 squared is 1 times a negative 4 is a negative 4. So that means that a equals a positive 2. So then f of x is equal to 2 times x minus 1 squared times 3x minus 4. All right, next one. I have 4 zeros here, so f of x is equal to a times x plus 3 times x minus 3 times x plus 2 square roots of 2 times x minus 2 square roots of 2. Then I use my y-intercept. Negative 72 is equal to a times 3 times negative 3 times 2 square roots of 2 times negative 2 square roots of 2. So we get negative 72 equals. All right. So 3 times a negative, well, first of all, when I multiply all this out, it's going to end up being positive, so I don't have to worry about the negative 3. So 3 times 3 is 9, and then 2 square root of 2 times 2 square root of 2. 2 times 2 is 4. Square root of 2 times square root of 2 is 2. So when I multiply these two together, I get 8. Multiply these two together, I get 9. So I get 72a. So a is negative 1. So f of x is equal to negative x plus 3 times x minus 3 times x plus 2 square roots of 2 times x minus 2 square roots of 2. There's your complete factorization. All right, then last but not least, we are going to sketch the polynomials. They're already factored for you, so it makes it a lot easier. So I need the degree. I have squared and cubed into the first. So this is 5. The degree is 6. In behavior models a quadratic. It's positive, so it's going to be up, up. My x-intercepts, x-intercepts, not zeros, so they're ordered pairs. So I have 2, 0, negative 3, 0, and I have negative 2, 0. So I need to look at what's going on here at the positive 2, okay, which is this one right here. This is going to be a bounce, so we'll be there for bounce. And then here I will have a wiggle, so I'll put a little W for a wiggle. And then this is just a boring old pass-through. All right, so I have to find my y-intercept. That's when x is 0. So y is equal to negative 2 squared times 3 cubed times 2. So negative 2 squared is 4. 3 cubed is 27. And then times 2. All right, so 2 times 27 is 54. Then 54 times 4, so 54 times 2 is 108. 108 times 2 is 216. So my y-intercept is 0, 216. Then I put this on my graph. I only have to go out to 3, so 1, 2, 3, 4. 1, 2, 3, 4. This is a positive 216, so I'm going to just plop it up there. Then I'm going to put my points on here. I've got 2, negative 3, and negative 2. And then I have 216. My end behavior is up, up, so I'm going to start up here. I'm going to bounce at negative 2. I'm sorry. I don't bounce. I'm here at negative 2. I should have written these in order for myself. So I'm just going to go straight through negative 2. Then I come up through negative 3, and I got a wiggle. That might be a little challenging. And then I got to go up to 216, and then I'm going to bounce right here. Okay, so let me think about that again. I got to go down here, and when I come up, I got to wiggle. So the wiggle is going to kind of be like that. I think I might just go ahead and do that much so that I can connect it. So I'm going to start up here. I'm going to come down and then back up. So I connected it without making it pointy, right? And then I keep going. I got to hit 216. And then at 2, I'm going to bounce and come back up. And there's my sketch. All right. So on this one, I got a squared and a squared. So that means the degree is 4. It models a quadratic again. So this is going to be down, down. My x-intercepts is going to be at negative 1, 0 and 2, 0. Then I have to find the y-intercept. So that's going to be y equals negative 1 squared times negative 2 squared. So that's negative, so 1 squared is just 1. And then negative 2 squared is a positive 4, so it's just negative 4. So 0, negative 4. All right, so I'm going to get my points on here. 1, 2, 3, 1, 2, 3. And then I'm down here at negative 4. Put my negative 1 in here, my positive 2. Oh, I didn't mark my stuff here. So these are both squared. They're both even, so there's a bounce on both of them. Okay. My end behavior, oh, and I've got to go through this. My end behavior says I start down here. So I'm going to come down here. I'm going to bounce off of this. I got to go through my y-intercept, and then I got to bounce again. Okay, so it's going to look something like this. I'm going to bounce. I'm going to hit my y-intercept, and then I'm going to bounce, and then I'm going to go down like this. Something similar to that. Okay, so make sure not only that you've done this review, but that you have also looked over your notes, gone back over your old quizzes, maybe do some more in Delta Math, but actually come prepared for this test. You can do well.